Thanks everybody for joining. My name is David Macias. I'm a lead product marketer at MongoDB. I'm with my better half, Prakul Agarwal, product manager for ML and AI at MongoDB. We're going to talk a little bit about building generative AI powered applications, even leveraging streaming data and Confluent Cloud. I will talk most of the first half. We'll keep it at a very high level, kind of go Gen AI 101 intro stuff. And for some of you, that might be a little bit boring and behind you, but hopefully for some of you, that's a little bit informative. We'll show a little bit of a clip of a demo of you using MongoDB and Confluent. And then Prakul will talk a little bit more about leveraging MongoDB's Atlas vector search. So I kind of just covered this agenda before even pulling it up. So I'll just move forward. High level, what is generative AI? A generative AI powered application. Again, maybe this is just old news for all of you, but with ChatGPT being released in late 2022, really put generative AI at the forefront of in a lot of our minds. And so obviously with that, you can write a textual prompt to get something like a nice novel poem created or generated. Or like on the right-hand side, you see Adobe's Firefly, which is embedded in some of their other products like Photoshop and whatnot, where you can use natural language to prompt new generation of image fill or just a new image general. So at a high level, it's AI or artificial intelligence, hardware, software that can generate or create something new when asked through a prompt. And a little bit about what we're seeing, right? So MongoDB Atlas has recently announced MongoDB Atlas Vector Search, which allows for generative AI-powered applications to be more easily built on MongoDB Atlas. And some of the things we're seeing in the industry, you might imagine from kind of left to right on the screen, the more common use cases, chatbots, right? So and making these more informed by being able to use semantic search, being able to have a more kind of human-like interaction with the chatbot. One of the things we'll show a demo in between my section and Prakul's that leverages MongoDB and Confluent is the ability to make like a 360 or single view of a lot of your data and then augment an LLM with that data and make that interactive through natural language. We're seeing this across several different industries, from large consulting firms to healthcare, insurance companies who need to basically leverage structured and unstructured data in a single view and allow either internal or external stakeholders to interact with that data through natural language, because a lot of those stakeholders may not be technical. And then the industry term, mind-blowing idea, right? There's a couple of things that we're seeing on the fringe that I think is really interesting about generative AI. I'll cover one of these in just a second. But different auto industry, chemical companies that are using it beyond just text-based generative AI use cases. So what does one of those look like? We have this global auto manufacturer who is basically taking the sounds that a car might make, engine, purring, whatever, little kinks that come up, feeding that through a generative AI application, right? Basically synthesizing that audio and being able to come up with a natural language diagnostic based on the sounds that they heard, so that mechanics are able to determine what needs to be done with the car. Ideally, this would add a lot of productivity and process enhancements to car issues and things like that. So that's just one example, kind of on the fringe. But I think what we're seeing is that while you start with maybe the chatbot, you start thinking about a single view of taking a lot of structured and unstructured data, and then running that through an LLM. There's a lot of these use cases out there that are quite exciting, and I think a lot of you all, the builders out there, are going to kind of see like, oh, what can I do with synthesizing, say, audio, video, imagery, and turning that into natural language text, or vice versa, for whatever your use case might be. And so I think just as an industry, we're at the forefront of that, but we're already starting to see some of these bubble up that we as a company are just like, oh, that's pretty stinking cool, like excited to see how that goes into production. So again, taking a step back, generative AI 101, like most of you hopefully have heard of the term LLM or large language model. You might also heard the term foundational model. At a high level, basic level, it's the general purpose brain that underlies these generative AI use cases. So if you think about OpenAI and ChatGPT would essentially be the generative AI powered application with the model GPT. There's a GPT 3.5, now a 4.0. That's the underlying LLM. And a similar, Meta has their own, it's called Llama, their own LLM that's open source. Adobe has their proprietary large model that's able to create a lot of their image generation. So again, the LLM is essentially the large brain underlying the generative AI powered application. And these LLMs are great in the sense they have so much knowledge, right? Most of them have scraped the entire web up to a certain time, and they can answer really great questions. But sometimes when you get real specific, or for your company use case, it may not be all that useful. So as I said, I'm a product marketer, but imagine, kind of seller. And so if I had this use case where I'm saying, I prompt ChatGPT, and I actually put this into ChatGPT, like, how do I sell, MongoDB and Kafka to my current accounts based on their current upcoming priorities? Well, again, because ChatGPT has data up until about a couple years ago, I think it's September 2021, its response was pretty generic. It was, it's flexible, scalable, performant, highly available. Like, true, great things about MongoDB. I don't want to undersell that. But at the same time, didn't mention MongoDB Atlas, our cloud-managed database. Didn't mention Confluent Cloud, which you would think it would think when mentioning Kafka. And it didn't, it says tailor these points to an engineer leader, as opposed to, like, if it had access to some of my account data, it might say, this champion at this company, et cetera, et cetera. So, how do you go from making an LLM, a nice general purpose brain, to a well-trained LLM that's refined with multimodal data? I mean, pretty straightforward. You give it access to some of that proprietary data, whatever form it might be, right? It might be some of your telemetry data that's stored in your operational database. It might be, in cloud storage, and it might be in different formats, whether that's, unstructured data types, like, again, like I've mentioned, audio, video, imagery, it might be social media feeds, things like that. And so what does that process look like? This is a little bit abstracted and basically, simplified. But one of the things that we're seeing a lot of our customers do, or they're interested in, and we're hearing in the industry, is a process, and maybe some of you are very familiar with this, maybe it's new to you. It's a concept called Retrieval Augmented Generation. That's the process of taking a prompt from a user that doesn't really have any proprietary context, adding some context to it through proprietary data, then feeding that prompt to the LLM so that you get a more specific, well-informed answer. So I'll kind of walk through this. So say I ask it the same question. How do I sell my MongoDB and Kafka accounts based on current upcoming priorities? Well, you turn that prompt into a vector embedding. And if you're not familiar yet with what vectors are, vector embedding, three different terms that essentially mean the same thing. You'll hear them used interchangeably. You turn that into a vector. You then perform what's called vector search that allows you to retrieve semantically similar, so data that has like underlying similar meanings, so that you can retrieve the most relevant contextual data, and then augment, so right, kind of hearing some of the words in that RAG, augment that prompt before it's sent to an LLM. So essentially that prompt now becomes, how do I sell MongoDB, Confluent, MongoDB and Kafka, taking into account their Atlas usage, some call transcripts, maybe I have screenshots or images of some whiteboarding I did, things like that. So taking some of that data and then feeding it to that general purpose brain, and I get a more specific, well-informed answer. Consider pitching MongoDB Atlas and Confluent Cloud. They work great together for real-time apps. And just even at MongoDB, we've had some teams build these internally. Like myself as a marketer, I have questions on who's using what in what region, et cetera, et cetera. We've had some of these generative AI-powered applications built just internally facing that allows me to be able to essentially query our app usage and customer data with natural language. Like I don't even have to know how to write our MongoDB query language. So that's just one of the ways that we're doing it internally, but you can see how it can really empower stakeholders internally and externally to take advantage of all the great data that you all have stored, streaming or otherwise. So take a step back in case you didn't really know what vectors are, or vector embeddings. I mean, they're essentially an array of floats, with each of these floats representing the underlying meaning in data. So in this particular use case, if you look on the right-hand side, I have embeddings that represent snippets of text: cat, kitten, dog, or house. And in that first column, that first float in that array might represent, is this thing a living being, yes or no? You can see that the value for cat, kitten, and dog are all very similar. And as you would expect, for houses, it's very opposite, right? And so what vectors do is essentially allow you to have all these dimensions. So one of the most common ones is OpenAI's A-to-text embedding, which is a vector size of 1,536, I believe. So that's a ton of dimensions, right? And to query all that could take a lot of time, but with a vector index, you're able to find a lot of semantically similar data very quickly so that you can retrieve it in a nice kind of user-expected app experience and send that semantically similar or like underlyingly like relevant data to that LLM. So this is where vectors and vector search come into play.
I'm going to skip to the demo.
Okay. Just real quick, one of the things that it takes for to take these from idea to production ready is to be able to do that RAG architecture very simply, quickly, with low cost and complexity. The flexibility to iterate with speed, and obviously, if this app blows up, you need to make sure it has the ability to scale and be secure. So MongoDB, we've recently brought Atlas Vector Search embedded into the operational database to make that RAG architecture more simple. And they were built on what we see as like the industry-leading developer data platform that's battle-tested over 15 years, used by large banks, gaming companies that can scale very quickly, horizontally, and is secure, and is also available in all the different clouds. So with that, I'm going a little bit quickly. So we're going to go into a demo that's built on Confluent Cloud and MongoDB Atlas. Sorry, I realized the audio is coming through my.
Cloud and all speaking to.
Well, we have to.
ChatGPT-4 to give
Is that going to work?
Product recommendations based on prompts. Yes, could you give me the top 3 fancy restaurants in Dallas with their dress codes, please?
Of course, Britain. Here are the top 3 fancy restaurants in Dallas and their dress codes. 1. The French Room, located in the Adolphus Hotel. It's known for its refined European cuisine. The dress code is business casual. No jeans or shorts are permitted.
We're going to actually go against MongoDB to perform a vector search with the product recommendations that have been prompted. Can you please give me some recommendations for the dress code for option number 1?
One moment, please. I am traversing a large language model for your request.
Sure. Based on the given context, here are some fashion recommendations for a business casual or semi-formal dress code.
I think what was really interesting about this, all the recommendations that were coming in from a proprietary data set that was taking into account the user, their location, history, what timeline they wanted that items to be delivered. So this is exactly an example for like an e-commerce based use case. So audio gets converted into text using a model called Whisper that gets searched against MongoDB vector search, which can basically take a view over your 360 data to be able to give you most appropriate responses, be aware that certain inventory items are going out of stock, so not show those as recommendations, etc. So I'm going to essentially talk about MongoDB Atlas Vector Search, the technology that can really power this kind of transformation and all the incredible examples that David talked about. So what does native vector search mean? So at a very core, we essentially introduce this concept of vector embedding. So right alongside your regular data, your dates, your description, in this case, there's a content field. Right alongside there is a vector embedding field for it. This is something you would use like a large language model to generate. And this would sit right inside your MongoDB database alongside your operational data. So once you have that, this is how your index definition would look like. So this is something you would define once against your vector embedding field. There are a couple of parameters, customizations that you would be doing, chiefly like the dimension of your vectors, which will depend on the large language model you're using, to the similarity metric. So MongoDB Atlas Vector Search essentially allows for 3 types of similarity distance score. And you would have your other kinds of things. So if you want to have a text-based index as well, you can do that. So once that index is defined, your query at the application runtime essentially evolves to this. There is a $vector search stage where you would essentially pass your query vector. You will specify how many results which are similar to it that you would want. So David talked about examples being like house data, etc. So this is where you would just power that. And alongside this, you can pass on your traditional point and range queries. So maybe give me all the movies which are sentimental but released before 1970. So 1970 exact match is something you would want date, and the semantic piece is something it would automatically recognize without you having to do anything. So with that, I'll just give you an example of a semantic search example, right? So in this case, a natural language query like houses in New Jersey with a front yard, which are less than 500K, is as simple as this query once your data has been processed and put into MongoDB Atlas vector search. So just very quickly, what is the technology that powers this? There is a graph-based algorithm called HNSW, which allows for this kind of efficient querying across your vector embedding points. And these queries are essentially something called as ANN, approximate k nearest neighbors. In the interest of time, I'll just leave the slide and move on, but HNSW is the keyword. So how do you think of building your applications, right? So when you were thinking of building this stuff out, some of them could be very easy to get started. So with MongoDB Atlas Search, we have a ton of industry AI ecosystem integration. So LangChain, Llama Index are two very popular developer libraries where you would be using a bunch of these mechanisms for taking your data, chunking it, how do you want to test out with different embedding models, to being able to have different kind of retrieval chains. So all of that will natively be saved into MongoDB and Atlas Vector Search. There are a lot of these large language models. So currently, in the proprietary AI models, OpenAI, Cohere are two of the leading models. So they work efficiently. They are partners of ours, as well as ton of open source models that you can use, right? So with Hugging Face, which is a partner of ours integrated with Atlas Vector Search, you can try out different open source models in a very native fashion. So with that, I just want to touch a little bit about multimodality, right? So what does multimodality mean? So we talked about a lot of the text data, but typically you would also have images and audio and video, right? Which till now has been a very expensive proposition to actually manage and use as part of your application, to getting insights, to serving customers for experiences. So with MongoDB Atlas Vector Search, that process becomes incredibly easy. So how do you connect your text and images? So there is this model from OpenAI called CLIP, which stands for Contrastive Language Image Pre-training. And essentially what it does is embeds your text and images in the same latent space, so you can search for one against the other. So just to give you an example, right? So you would have seen a lot of those, find similar images, or given a text, find me images, or given an image, generate description for it. So that's what this kind of multimodality brings into picture. And the process is incredibly simple, right? With these large language models and Atlas Vector Search. So the query that I showed you before, this is what it would look like. You would essentially take all your images, pass it to these models, store their vector embeddings, and your query looks just like this, right? So houses with swimming pool, and this is the kind of results that you can get. This was on a fairly large data set and took less than an hour to put together, for instance. So something similar on the lines of image similarity search. You can just give it an image URL, and you would find other images within your data set, within your enterprise data, which are similar. So that's where some of those similar image recommendations work. So with that, yeah, that was all we had for you. Thank you so much. If you have any questions, we have some time and we'll be around. Thank you.